Hey, good morning. Sorry for the delay. So, hey, good morning. Sorry for the delay. I was stuck in jam. Let me share the link. So, mm, mm, all right. Okay, good morning, everyone. Can you hear me good? Cool. Okay, so this is not the easiest of the topic that we've seen this week, and it's also one that you don't need to complete the 5 levels, but this is more advanced. So essentially, we're talking about what's happening when we upgrade a canister. So you remember that we have deployed, and you've probably deployed already tens of canisters. So we have an initial canister. Let's do a counter, so a simple counter. And we have a function to increment the counter. So counter is equal counter plus 1. And then we return the value of the counter. So the first time we are installing. So this is when we create our canister. So we have a canister ID. And then once we have the canister ID, we install the WASM, the WebAssembly module inside of it. So we can try. So 1 and 2 and so on. But maybe we want to add a new function. So we want to be able to increment the counter by any value. In that case, we create this function add. And this time, we are not creating a new canister. We are just upgrading it. So we are replacing the module. And you can see that you have different options. So you have the options to upgrade or the options to reinstall. Let's see. Let's see first what happens when we upgrade. So remember that the counter was valued at 2. And now it's back to 0. I've actually, maybe this one would be simpler to understand. So we are increasing the counter by 1. So it's now 1. So it meant it was 0. But before it was already at 2. So you can see already that when we upgrade a canister, we lose all informations. It kind of resets to the original state, which was 0. And so this is because you have the concept of stable memory and heap memory in a canister. So canister has two types of memory. The first one is this heap memory, which is the one that is reset and deleted when the canister is upgraded. And usually when you define variables, they are defined in the heap. So this is defined in the heap. There is a way to counter that by using what's called stable memory. So the stable memory survive upgrades. And I can go maybe a bit more into details about those memory. They are really different on the, so if you were to look on the like source code of the internet computer, how the canister environment works, this is a really complex topic, but the WASM heap is limited to 4 gigabytes because it uses something called WASM time, which is a runtime of WebAssembly, which is it's indexed on 32 bytes. So this means it's limited to 4 gigabytes, like when we had the old Windows version, we also had this 4 gigabytes limitation, which is essentially what 32 bytes enable you to access memory. It should be upgraded at some point. So there is something called WASM64, which should essentially move the WASM runtime from 32 bits to 64 bits. And if this is the case, then we have a kind of a very, very, very big heap. I think that would be 256 terabytes of memory. So that's pretty good. And yeah, so you can see the heap as a, it's like a pile of memory. So you can allocate and deallocate. And it's also the fastest memory available to the canister. So it's really kind of native memory. It's really, really fast to access, but it's limited in size currently, only 4 gigabytes. And it is also reset during upgrades. The other memory, stable memory, is up to 48, and actually it's now, I think, 96 gigabytes of storage. So it's really, really big. You can almost store like 100 gigabytes. So it's pretty good for something that is on the blockchain. And everything in stable memory survive upgrades. So this is really good because you don't have to care about am I going to lose my data or not. The downside is that stable memory is slower to access than the memory in the heap. This is due to this runtime environment that I was talking about. So WASM time is the runtime. And if you want to access the stable memory, you have to get out of this runtime and you call like an external API. But yeah, it's not necessary to understand that. If you want to understand that, there are really, really good explanations on the forums and on the documentation. But once again, this is kind of a complex topic. So one question that I always get is, which memory should I use? And there is not a simple answer to that. This is kind of the downside of being like working on new technologies like this, because things are always evolving. For example, when I started on the IC, the stable memory was only 4 gigabytes. Now it's 96 gigabyte. So that kind of changes the answers to this question. And also stable memory was very, very slow when I started. Now it's not so slow anymore. It's slower than the heap, but it's, I think, like 5 times better than it used to be. So I would say for you, in the bootcamp, we don't really care. You can use the heap. It's enough. I mean, we are not going to go above 4 gigabytes by far. If you were to build a real project, it depends on your requirements. But usually, for example, for the bootcamp dashboard, I think that if we reach a point where there is more than 1,000 graduates, and maybe I want to, for example, add a profile picture for all of you. So like, so you can add a profile picture that is displayed on the dashboard, and you can have a profile with a bit more information. Then I think I would need to move to stable memory at some point, because if you're storing files or videos or pictures, it's really, really easy to take space. So yeah, there is not a easy answer to which memory should I use, but for simple purposes, it doesn't really matter. In Motoko, we have a concept that essentially abstract away stable memory, and this is stable variable. So stable variables are variables that are stored in the stable memory. But actually using the stable memory is kind of hard. There is a interface that you have to call. It's very, very hard, very low level. But we have the luck with Motoko to have this concept of stable variable. So let me show you how I can define a stable variable. I can just add the stable keyword. And this is going to be a stable variable. And so now I'm going to add a query function that show the counter. So see, show counter. Okay, so we are still at 0 because we've restarted, and we didn't have the stable variable in the previous example. So when I upgraded, the variable was not stable, so it has been reset. But now it is a stable variable. So let's see if we do a few increments. So I've clicked a few times here. So okay, 1, 2, yeah, 1, 2, 3, 4, and maybe I can add 5. So it should be at 9. 9, okay. So yeah, counter is at 9. And I want to add a new function, maybe multiply that. Let's do just multiply. That will essentially counter is equal to counter time n, and then we return the counter. This time I will upgrade. And what do you think is the value of the counter now? Yes, 9. So this is the power of stable variable. Really cool. Notice one thing, you could still reset the state. So maybe you don't want actually the counter to keep this value in memory. In this case, you need to reinstall. When you reinstall, it doesn't matter if you have a stable memory or a stable variable or not. This will just restart from a fresh memory. And so the counter is going to be 0 in this case. So that's what the chapter 12 is about. By the way, yeah, this is from the repository. So stable variable. Essentially, you just need to add stable in front of your variable. So this is as simple as that. It would be really cool if we could use stable as easily as that for all our variables. But this is not the case, at least right now. I know that I had some discussions with the Motoko team. So the team that is basically building the language itself, they want at some point to make it so easy to use so that basically you can declare stable for any variable, any type. And that will make the experience of building with Motoko really, really cool. But right now it's not the case. And unfortunately, we cannot do some things like this. So for example, if I were to declare a hash map, so this is something we've used this week, and this is like a super important data structure in Motoko. Unfortunately, this is not going to work. I can already spoil you. yeah, so this is, maybe we can replace it by nat, for example. We just want to store numbers. And I want to import principal. Okay. Variable map is declared stable, but as non-stable type. So there is a concept of stable type in Motoko, which is all the types that can be declared stable. So for example, int is a stable type. Nat is also a stable type because this worked. But hashmap is not a stable type. Why? Because hashmap is a class. So we have functions that are defined on the type hashmap. If we look, actually, this is a good example. We can look at how the hashmap class is defined. This is in this repository, which is it's the Motoko base library. So every time you are importing code, this comes from here. And if we look here, hashmap.mo, so yeah, it says class hashmap, provide a hashmap. And basically this is because, yeah, it's defined as a class. And a class is an object which has methods on it. So you have functions. Yeah, you have functions. And this is never stable. So all the types in Motoko that are defined as class, and hashmap is not the only one. You also have treemap, buffer, and a few others. They are not stable. And they cannot be declared stable. All the primitive types, so what I call primitive types, are here. So nat can be declared stable, text can be declared stable. We can try. So stable var name. This works. Stable var students. So this is also stable. An array with a stable type is can be declared stable. All the bounding numbers. So we haven't seen that too much, but you have this concept of nat8, nat16, and nat6, nat32, nat64, and same for the ints. All of them can be declared stable. Float, characters, boolean, and array, as I said, can be declared stable. Good thing, though, community members are working on stable structures and stable libraries. So it's possible to essentially rewrite how the types are defined to have them as stable. For example, stable buffer is an attempt, and actually I think it works, to create a library for a buffer that is stable. So you have to kind of change how you define the buffer library. You have to, it's more complex than just doing a class, but it's possible. And so it's time for me to introduce maps, which is the, no, it's not this one. It's the package manager for Motoko. So this is here. It's fully on the IC as well. So you can upload packages and you can download packages. And those packages are essentially written by community members. So people that are also using Motoko for their project, and they notice that some part of the languages is missing, some packages are missing, and they essentially write all of the code and then share it. And you will notice that we have a lot of packages where essentially it's a stable structure. So for example, map, which is really, really good. And if we had more time, I would probably make a lecture about it, or like I would at least recommend to use it, is a stable hash map. So they've built a whole package and you can use it and it's stable. And this is cool. You have a vector, which is also, I don't know if the vector is stable. Is it stable? Oh yeah, vector can be declared as stable, and also apparently vector is more more efficient than buffer for some reason that are specified here. So yeah, you can see that you have quite some packages like this. And mops is really easy to use. So there is the documentation here. You just need to install it. If you're familiar with npm, it's very, very similar. And then you just add packages with the name like this, and then you can import them in your code. So really, really good mops. I recommend to take a look. And I will provide the link in the chat. So I see one question, can we make custom types tables? So object, which like you define as custom type, for example, you're talking about like the custom types we've defined, for example, in the level 3, I believe, we have the concept, no, level 2, we have the concept of a member. I guess your question is, can we declare this as table? And the answer is, it depends. So if you have a custom type, actually, you cannot define the type as table, but we could do, let's first member of type member. So this would be a member. Can we declare this member as table? Yes, we can, because all the types, all the fields are stable. I said text can be declared as, let me remove that actually. So text, the name is of type text, and text is a stable type. The second field is age, which is of type nat, and nat is a stable type. I don't know why this is doing those animations. So you can declare something like this table, but if you add a field like, this is kind of strange, but like map, and then here you use a hash map, or you use a buffer that is not stable, you could not, yeah, let me actually try to do that. So let's see, you have a, what could we store? Maybe we could store your proposal IDs. So I want to store in the member object, I would like to store all the proposal that this person has created for some reason. And I use a buffer to do that. So I need to add this here. And I will start with an empty buffer. So this cannot be stable. Variable first member is declared stable, but as non-stable type, because this is not stable. So to answer your question, yes, you can, if all the fields are stable, but if one of the field is not stable, then you cannot do that. So like this is fine. Okay, so let's go back to our chapter. Maybe before I go more into the rest of the lecture, is there a question about stable types, stable variable, stable memory? Hmm. Is there additional cost to using stable variable? I believe yes, it's a bit more costly. As I said, so it's not like a native memory. So you have a few more steps when you use the stable memory, and this is like abstracting the way you don't need to take care of it, but behind the scenes, with the stable keywords, essentially the Motoko language is kind of serializing and deserializing your variables. And I believe that yes, that adds some cost. I think it's negligible though. Like if you really had a big application with a lot of users, you would notice a difference, but for most of the cases, you wouldn't. Okay. So next thing is experimental stable memory. And this is really not something that we need, but I just want to talk about it. This is a library that enables us to directly use the stable memory, but this is like you can essentially use bytes and put the bytes in the memory, and then you can get them back. So for example, if you're writing a library with stable types, you would probably need to use something like this. Otherwise, yeah, there is not really use cases for this, but I just wanted to mention this exists and it enables access to the stable memory directly. Now there is something else, which is being less and less used, but I still use this pattern. It's essentially the system function. So system func pre-upgrade and system func post-upgrade. And I want to mention that because you will probably find it in some documentation. It's a pattern that we use in the early days. I don't think it's going to be very much used in the future, so don't worry too much about it, but I still want to show you how we used to kind of solve the problem. If you don't have a stable structure, how can you essentially keep your data between upgrades? So we've said that we want a hash map, which is not stable. And we have members. So I will define a member as a name and an age. Okay, so now I'm changing the logic of this canister. Let's say add member. We take a member and we let next ID. So we are counting the members by ID. And every time we add a member, we are increasing next ID. So I need to make it a mutable variable. Okay. Yeah, this is dot put. And then I have another function, show members, which return all member, maybe with their ID. So like this. I will keep this in comments for now. I will remove that. And this is returning let me see. Okay. So here what I'm doing is just it's I don't know if it's something we've seen already, but I'm just using the iterator library. So the iterator is something that you can call multiple times, like we use, for example, for the loops. And I'm using this to transform it into an array. So two array. And the iterator that I'm using is map dot volt. So I'm iterating over all the member in the map. And so that should give us all the members that are in the map. Okay, so let's deploy this. Yeah, so we have some issues, but it's not a problem. So if I click here, there is no member in this map. We are going to add some of them. So this isn't like this. So let's add one, then we can add two. Another one. Okay. Now we can see them. All of them. And so I guess if we have a new function, maybe I don't know, I want a function that's just greets. It just returns hello world. How am I going to save all my members? Because now if I want to check my members, they are not here anymore. But remember that we cannot do this because we have a map, hash map, and a hash map is not something that we can declare as stable. So how do we solve that? How do we use to solve that? We use system function pre-upgrade and system function post-upgrade. So this will execute code before upgrading the canister, and this will execute code after upgrading the canister. What we would do is create a stable structure that essentially would save our members in stable memory and then put them back in the map. And so we can do that stable var map entries. So we would call that, for example, map entries. This would be an array with nat and member, and it would essentially be empty when we initialize it. But in the pre-upgrade, we would do map entries would be assigned to iter.toArray of map.entries. And in the post upgrade, we would do so let's say map would be equal to maybe we can do a loop that would be easier. So we would do for ID and member in map entries dot values map dot put ID and member. And yeah, the syntax is like this. So we need to add the parentheses here. Okay, so what we're doing here is basically we take this, we put every information that is inside of this in the map entries here in the pre-upgrade, and then we put it back and we reset the map entries. Also, we would need to make this one stable because we don't want to reset the ID to 0. Okay, so if we do that, we should keep all of our members. And so the functions that I'm using is map.entries, which essentially gives you an iterator that lists couples of items. So it lists all the ID with the member. And then I'm converting that into an array with the iter.toArray method, putting this here inside of the map entries and doing the opposite in the post upgrade. Okay, so I will try. And once again, this code is not yet in our canister. So when we do this first upgrade, we still lose all of our members. But now, I add a few members. And let's say I have a new function that is doing absolutely nothing, but I want to add this one. I upgrade. This time, I still have all of my members. And that's how we used to do it with those post-upgrade and pre-upgrade. So yeah, this is kind of a trick that you can use to make sure you don't lose data. And it's kind of a dangerous pattern. I think it's going to be removed, or at least, yeah, I would suggest to use more stable structures now. Essentially because if something goes wrong, you kind of can, it's kind of a risky operation. So maybe we do something wrong here and it's in the pre-upgrades or post-upgrade and we cannot save our canister. So for example, you can totally, if you do that, so this is going to trap And we haven't seen too much what is a trap, but essentially it's kind of the canister is kind of crashing, so getting out of its execution environment and not able to resume the computation, not able to finish the code. If you do that, and here, of course, I'm doing assert false. No one would do this, but maybe the trap can happen without you being aware. So maybe you have something wrong in this map, and there is something like you get out of index. You try to get into an array. You don't have enough index, so you trap. And now you will see that if I try to upgrade again, so for example, if I try to upgrade, I cannot upgrade anymore. So my call was rejected. Canister, so this is my canister ID, trapped explicitly, assertion failed, line 36. So I assume it's referring to this. I don't know why it's 36. It should be 40, but maybe, no, it's not a problem. I don't know. Anyway, it's trapping before my upgrade because it's trying to run this and it's running into this line, which automatically trap the canister. And there is no solution to this because now every time I try to upgrade, the pre-upgrade methods is initialized and this is run. And the only way to change this code would be to upgrade, but every time I upgrade, there is a pre-upgrade method. And when you do this, there is no way to recover your canister. And yeah, that's not good. So that's why this is kind of a dangerous pattern. If you have in post-upgrade, it's not so much of a problem because the post-upgrade could be modified because you can still upgrade and then the new code will execute. But the pre-upgrade, if you miss something, then your canister is not recoverable anymore. So let me take some question. Maybe in the future, they will allow stable, dynamically sized object with specified pricing. Not sure, but yeah, basically the Motoko language is evolving. And so they are working on abstracting away this concept of stable memory and making all the variables in Motoko stable by default without even you having to write stable. I think this will require quite some trick on their side, but this is something that should be doable, and also working on like optimizing the cost and the speed. So this should be really good. Can we still use off-chain database solution with REST API calls? Well, it depends, but you could take your data from the canister and put it off-chain. I know that some projects very early did this because they wanted to make sure they would not lose all their users in case something got wrong. And but there is no way to there is like no, how to say it, native way to do it. So you kind of have to extract the data and then put it back off chain. Can we use external SQL, NoSQL databases for backup? Yes. Yes. But you have to kind of write all the code for that yourself. So you have to essentially, the way to do it would be to have like scripts, like functions that you can call. So here, for example, get all members. Then you have a script somewhere in your code. You used maybe the JavaScript agent. You call the IC, you get the data, you store that locally, then you store that in your database. Yes, it's possible that Autornot is doing this. Okay. So then, yeah, I think I've already talked about this in yesterday's lecture. So this is not related to the memory. This is related to the interface. So when you upgrade your canister, there could also be problems with the interface that you change, because your canister can be used by other persons. And if you remove a method or you delete some parameters, you change the function types, your clients, so the people using your canister could also break your codes. They would break using your canister. So this is a separate topic, but it's also in the chapter 12, because it's related to the fact of that you upgrade a canister, and you have to take this into account. The good thing is that automatically with Candid, you have upgrade compatibility check. So Candid will check your interface, and also DFX and the playground. I believe the Motoko playground also does it. Compare your stable signature to make sure you won't lose any data when you are doing complex operation. And you will see, for example, this message: Candid interface compatibility check failed. You are making a breaking change. Are you sure you want to upgrade? So this is great solution to have. And as I mentioned, this verification does not guarantee that the upgrades will go through. You can still have problems, but it guarantees that if the upgrades goes through, you won't break existing clients and you won't lose any data that is marked as stable. So that's at least one guarantee that you have. Okay, I think that's it about stable memory. If you want to dive more, again, there is really a lot that can be read about that. But yeah, this is what you need as a Motoko developer, I believe, to navigate this. So we have still 5 minutes. I can take more questions. Otherwise, next session is with OpenChat. So I want everyone to be here. It's going to be different from the sessions we've done, because it's going to be more live session. I will ask them questions about why they've decided to create OpenChat, what kind of technical issues they run into, how was the decentralization sale. So they've been raising 1 million ICP using the SNS, which I've talked about. So I want to ask them like how the experience was and all sorts of questions. So yeah, make sure to plug in, because this is gonna be a great one, and it's it's a good opportunity to really see what's happening. Okay, no question. See you in 3 hours. See everyone.